Hello and welcome back to Humanizer, where I'm converting the MPFB plugin from Blender into Godot. This is part 2 of automating the clothing import. So I've got the basis shape attached to the bones. As you can see, it follows the skeleton now. And it does not have all the shape keys, so it doesn't quite fit, but I'll do that next time, and I still need to add the texture as well. So that will be in a future video, and then I'll upload all of it to the repository once the entire clothing process is working. So I'll go ahead and show you how I got this to work. Last time I generated the array mesh for the clothing from the OBJ files that are included in the MPFB2 system assets download. So this time I need to attach it to the skeleton and generate the texture as well. So you can see if I attach it to the skeleton that it does not move with the animation at all. So, and I'm going to need the bone weights from the helper geometry, but the current helpers blend file that I'm using only has the mesh. I didn't attach it to the rig, unfortunately, so I need to export that from Blender first. So I'll make a new project in Blender and get rid of all of the objects and the existing collection. So we're at the root node. Then I'll make a new human from scratch using MPFB2. And under the data, I'll disable all of the shape keys so that we have the basis shape. Then under rigging, I'll add the Mixamo rig. And then under the modifiers on the mesh, I need to delete the helper, the hide helpers modifier. So now we have all of the clothing and hair helpers. And then I'll save this in the Humanizer project as rigged helpers. I don't want to overwrite the existing because I don't want to break anything. At some point, probably next video, I need to actually generate the base human mesh from the helpers, since I'll be changing the skeleton and that will streamline the conversion. So now if I add the rigged helpers and make local and modify the skeleton rotations, you can see that the helper geometry is now attached to the skeleton. So I'll double click the rigged helpers.blend to open up the advanced import settings, and on the base mesh, enable save to file, and then set the save file to a new rigged helpers resource and re-import. So now I'll make a new scene to load the bone weights data, and I'll save it in the skeleton builder folder. Then I'll add the rigged helpers mesh as a child of the scene and attach a new script. Now I want to make new variables for the surface arrays, the bone count, and the Blender to Godot index. And on ready, I'll set the surface arrays equal to the rigged helpers.mesh.surface get arrays on surface 0, and the bone count is the surface array's bones array size divided by the vertex array size. And I'll set the blender to go.index using the create unique index function on the surface array's vertex array. And this will just get the unique values from the array and index them in the order. And I'll print out the bone count just to make sure that's working. So this mesh has 8 bones per vertex. So now I'll loop over the blender to go.index.size, and I'll get the go.index from the B to G index at I at 0, since it gets an array of all of the duplicates. And then I'll get the bones equal to, this will be the local, from the surface arrays bones array dot slice at the go.index times the bone count to the go.index plus 1 times the bone count. And I'll just print the bones array. So you can see that it gets all of the indexes for the attached bones. So now I'll get the bone weights from the weights array. And if I print that, now we get an array that adds up to a total of 1. So these correspond to the bone indexes from the bones array. But now I want to make a new output data array, and instead of printing this, I want to append it to the array. So I'll set the data equal to an empty dictionary and set data bones to an array and data weights to an empty array. And then in the for loop, I'll append the local bones and the local weights arrays. And then I'll use my save JSON function, which just uses the stringify to save the data dictionary in the build skeleton folder. and this will be the bone weights.json. So now if I run this, it generates a new JSON, and I probably can't open it in the editor, so, because it's too big. Oh, okay, so you can kind of see. Now before I add this to the clothing generator, I do want to open up the make human clothing reader, and instead of just storing the array of floats from the file, I want to parse this into the weights, bones, and offset. So I'll set the line dictionary equal to a new dictionary, and then I'll set the vertex equal a new array, the weight equals a new array, and the offset equal to a new vector 3.0. Then I'll loop over for I and 3, and I'll append the line array at I to the vertex array, and the line array at I plus 3 to the weights array. Then I'll set the offset.x equal to line array at 6, and the y is at 7, and the z is at 8. Then I want to multiply the offset by the skeleton scale, which is in the generate close mesh, and I got this from the rig.json. And then I'll append the line dictionary to the vertex data instead. So this will break the generate close mesh, but I'll fix that in the next episode before I upload to the repository. Now in the GLB to mesh generator that I made last time, first I'll make a new function to add the bone weights to the import mesh, which is an array mesh. Then I'll make a new mesh equals array mesh.new, and I'll set the service arrays equal to the import mesh dot surface get arrays on surface 0, and then I'll duplicate. Maybe you don't have to duplicate since it's returning from the function. And then I'll set the, then I'll make a new mesh, add surface from arrays, primitive type triangles, pass the new service arrays, and we don't have any blend shapes, so and then I'll return the new mesh, and then I'll make a new variable for the export mesh equals add bone weights on the import, and I'll save the export mesh with the resource saver instead, and then I'll just run this to make sure that it doesn't throw any errors. So now in the generated assets, the female casual suit is still intact. Now I need to get the MH clothing data. So, and this is in the MPFB2 plugin assets folder instead of the generated assets folder. So I'll probably end up moving that into the local folder, but for now this needs to be a relative path, and then I'll add the folder name to the save path and the load. Then I'll make a new variable for the MH clothing reader of type MH clothing reader. And after I get the clothes name, but before I make the export mesh, I'll set the MH clothing equals new reader, and this will be at the MPFB2 plugin / assets, and then I'll add so this part of the string, which is the base path, or the base directory. And a slash, and the clothes name, plus dot MH clothing. And then I'll just print the MH clo vertex data dot size to make sure that it loaded. So if I run this, it doesn't throw any errors, and it's loaded 2,876 vertices. Then in the add bone weights function, I'll loop over the Blender IDs in the make human clothing vertex data dot size, and I'll set the vdata equals the vertex data at the Blender ID, and I'll loop over the 3 vertexes, so for I and 3, and then I'll get the vertex ID equals the vdata dot index at I, and the vweight, vertex weight, is at the weights dot at I. So for now, I'll just print the ID and weight to make sure that it still works. So it's printing an integer and then a decimal, so it is getting the bone ID, or the vertex ID, from the helper mesh and the weight that you multiply by. So now I need to get the bone IDs and weights at the vertex ID from the bone weight JSON. So I'll make a new bone weights data equals utils read JSON, and this uses the JSON parse, and then I'll drag the bone weights JSON, so this will get the data, and then I'll get the vertex bone IDs equals the bone weights at the vertex ID, which is the Blender ID, and then I'll get so this will be bone weights at bones, and this will be bone weights at weights, and this will be the vertex bone weights. And I'll print the vertex bone IDs and vertex bone weights. So now we have the array of 8 integers for the IDs and 8 floats for the weights. And now I need to combine the 3 into a single array. So first, I'll make a new array for the bones and one for the weights. And then I'll loop over for j in vertex bone ID dot size. And I'll get the local weight equals the vertex bone weights at j, and I want to make sure that the weight does not equal 0 because that's a null bone essentially. So if not local weight equals 0, then I'll get the local bone equals the vertex bone ID at j, and I'll just print the local bone so now it's printing the index. Then I want to multiply the local weight times the vertex weight, and I'll check if the local bone is already in the bones array. Then I'll set the local ID equal to bones dot find the local bone, and I'll set the bones or the weights at the local ID plus equals the local weight. Otherwise, if the local bone is not already in bones, then I'll append the local bone to the bones array and append the local weight to the weights array. So now at the end of this, I'll go ahead and print the weights array and run that. So I printed out the bones as well, and now you can see that the number of bones matches the number of weights, but now I need to pad the array with zeros so that it's equal to the original length. So first, I'll get the bone count from the bone weights array dot bones at 0, since they'll all be the same. And then I can use that instead of calculating the size. And then I'll say while bones.size is less than bone count, I'll append a 0 to the bones and a 0 to the weights, and then it'll print again. So the dot size on the bone count. So now you can see that it's filled in the rest of the bones and weights with zeros. So now it's in the correct format to add to the surface arrays. And the while loop needs to move over a tab so that it's outside of the in3 loop. So before I can add it to the service arrays, if I just print the new service arrays at mesh.bones, you can see that the value is set to null. If I comment that, so I need to initialize the bones and the weights in the new service arrays first. So I'll set the new service arrays at mesh array bones equals a new packed int 32, and the new service arrays at the array weights is a packed float 32 array. And then I'll resize both of them to the bone count times the vertex array size. So we'll do that for both arrays. And now if I print the bone array size, it's 87,000, so now I can set the index to the value. Then I'll need to get the go.index from the Blender index. So first I'll get the clothes Blender to go.index equals the create unique index from the new service arrays vertex array. And then I'll convert the Blender ID into a go.id array equals b to g index at Blender ID. And then I'll loop over go.id in go.id array. Then I'll loop over for I in bone count and set the new service arrays at array bones at the go.id plus I equals to bones at I. which is the local array, and then I'll set the new service arrays at array weights at go.id plus I equal to weights at I. So the array bones and weights index should be GDID times the bone count plus I. So now if I run this and attach it to the closed demo, so you can see that it does move with the mesh. Now the sleeves are extended, and it's not right because the coordinates are rotated by 90 degrees, and so when it's pulling out, it's pulling up. So I just need to basically calculate the basis shape for the bones mesh for the clothing now. First, I need to get the shape key data array using the JSON parse function. So I'll read the JSON from the shape key data. And then I'll make a new function to make the basis shape, and this will take a import mesh of type array mesh. So I'll get the service arrays and make the new mesh, and then at the end I'll add the new service arrays and return the mesh, and then after I add the bone weights, I'll set the export mesh equal to the make basis on the export mesh. So this will take the bone weights and then set the vertex positions. Then I'll loop over the Blender IDs in the MH clothing vertex data dot size, and I'll get the vertex data from the MH clothing vertex data at the Blender ID. Then I'll set the new coordinates equal to vector3.0, and then I'll loop over I and 3, set the vertex ID equal to the vdata dot vertex at I, and the vertex weight at vdata dot weight at I. And I'll get the vertex coordinates from the vertex ID using the shape key data dot basis at vertex ID. But I'll want to, this will be an array because JSON can't encode vector 3s. So I wrote a function that converts arrays to vector 3s. Then I want to multiply the coordinates times the vector weight, and then I'll add the vector coordinates to the new coordinates, and then at the end of the loop, I'll also add the vdata offset to the new coordinates. Now I need to use the blender to go.index to set the vertex positions. So instead of recalculating the array, I'll just define it at the top and I can reuse it. Then after I get the new coordinates, I'll get the go.id array equals the blender to go.index at the blender ID, and then for go.id in the go.id array, I'll set the new surface arrays mesh.vertex at the go.id equal to the new coordinates. So now if I run this, you can see that the mesh is updated to a smaller mesh, and now I can reset the rotation and it will be oriented properly. And if I sort of line this up, it's not going to be perfect because I don't have the shape keys yet, and then if I play the animation player, so you can see that the close will follow the mesh now. So that seems to be working. Next time I'll do the textures and integrate it back into the generate clothing main script, and then I'll upload it to the repository. So that's all for now. Thanks for watching and have a great day.